Alright, so today is just a little review on simplifying radicals. And the first thing I want to talk about is the product rule. Now remember, the product rule for radicals just lets us take a radical. For example, the square root of 8 is the same thing as the square root of 4 times 2. And then we can break that up. That's the same thing as the square root of 4 times the square root of 2. And the square root of 4 is 2. So the square root of 8 simplified is the same thing as 2 root 2, or 2 radical 2. Let's try another one. How about the square root of 12? Let's see, the square root of 12 is the same thing as the square root of 6 times 2, but I don't see any perfect squares there. So let's try another one. How about the square root of 12 is the same thing as 4 times 3 under the radical? That's what I want to do. So the square root of 4 times the square root of 3 equals 2 root 3. So 12 is the same thing as 2 root 3. Let's try another one. What about the square root of 20x squared y cubed? Well, I just want to draw your attention over here to what x squared and y cubed looks like. That's x times x and y times y times y. So the 20 is easy. I know that you guys can do that with no real thought. That's the same thing as 4 times 5. And then when we see our variables, we're looking for pairs. A pair moves it out from underneath the radical. A pair will move it out from underneath the radical. Whatever is left is going to stay under the radical. So 20x squared y cubed underneath the radical simplifies to the square root of 4 is 2. I have a pair of x's, I have a pair of y's, and then I'm left with the square root of 5y underneath my radical. Let's try another one. I'm just going to make this one up. How about the square root of 40 x cubed y z squared? The square root of 40 is the same thing as the square root of 4 times the square root of 10. And then I'm just going to write these all as a product. X times times one more x. I have 3 x's. X times x times x times y times z times z. Remember, when we have a product pair, we can move it out from underneath the radical. So I know that the square root of 4 is 2. That takes care of that. I have a pair of x's that I can move out and a pair of z's. I am left with the number 10 underneath the radical, 1x and 1y. So the square root of 40x cubed yz squared simplifies to 2xz times the square root of 10xy. Cube roots really fast. Just so you're aware of what's going on. So if I have a cubed root, like the cube root of 8, just like when I look for square roots, I'm trying to find the pair. For the cubed root, I'm looking for triples. 2 times 2 times 2. 2 times 2 times 2 is equal to 8. So the cubed root of 8 equals 2. So let's try a couple of these. Out the cubed root of 64. Well, let's see. That's the same thing as 4 times 4, which is 16, times 4 more. So I know that the cubed root of 64 equals 4. How about the cubed root of x cubed? Well, that's the same thing as the cubed root of x times x times x. And again, just like with the square root, we're looking for a pair of terms underneath the radical. For the cubed root, you're looking for a triple set of 3 terms under the radical. So this simplifies to x. What about the cubed root of x to the 9th? Now let's think about our rules. The rules are when I multiply, I want to have 3 terms down here, and I want them to have the same power. So when I multiply a variable, if it has the same base, I do what with the exponents? I add them. 3 plus 3 is 6, plus 3 more is 9. So I have 3 terms, all the same, x cubed. So the third root of x to the 9th simplifies to x cubed. And one more example. What about the third root of 27 x to the 4th? So I have the third root of 3 times 3, which is 9, times 3 more, which is 27, and then x times x times x times x. Again, I'm looking for triples, so this is going to come outside, and this is going to come out, and I'm left with the cubed root of x. So the cubed root of 27x to the 4th is 3x, not x cubed, 3x times the cubed root of x. Let's do some quick practice. The square root of 24. Remember, I'm always trying to find a perfect square. So I know that is the same thing as the square root of 4 times the square root of 6, which equals 2 root 6. I know that it's all the way simplified if I cannot find another perfect square underneath the radical. Remember, perfect squares are 1, 4, 9, things like that. Okay? Let's look at the next one. The square root of 32x squared. Well, that's the same thing as the square root of 16 times the square root of 2, and x squared is the same thing as x times x. So remember, looking for square roots, a pair comes out. So the square root of 16 is 4. The square root of x times x is just x, and I'm left with a root 2. So 32x squared underneath a radical is equivalent to 4x times the square root of 2. Let's try one more square root. How about the square root of 200x, 200x to the 4th, y to the 5th. All right, remember, looking for perfect squares, so that's going to be the same thing as 100 times 2, the square root of 100 times the square root of 2, and then x to the 4th can be written as x squared times x squared, and y to the 5th can be written as y squared times y squared times y. I don't know if you can see I squeaked that in there. So let's see, the square root of 100 is 10. This x squared comes out front because I have a pair of them. Y squared comes out front because I have a pair of them, and I'm left with, underneath the radical, the square root of 2y. So the square root of 200x to the 4th, y to the 5th equals 10x squared y squared root 2y. Do you think you could do a couple of cubed roots? How about the cubed root of 125? Let's see, that's probably going to be a 5. 5 times 5 times 5, which equals 5. The cubed root of 125 is 5. And the last one, the cubed root of 1000, x to the 5th, y to the 6th. I'm going to rewrite this as the cubed root of 10 times 10 times 10, and then times x times x times x times x times x, and then 6 y's. And I'm going to use that idea of having triples again. So I have a triple, a 3 of a kind. So this 10 is going to come out from underneath the radical. And I have another 3 of a kind, x. And I have 2 y's, 2 3 of a kind, 2 sets of y's. What's left underneath the radical? X squared. So my real answer is going to be 10x y squared times the cubed root of x squared. And that's it. Good luck.